family related. We understand that, but if you can avoid holding out until Bart gives you your breaks, that would be great. I want to welcome you all here today. Thank you for being here. It's going to be sort of a long day for you, especially for those that are used to being out on the road. When we scheduled this in February, I thought, well, it'll be freezing outside and everybody will be happy to be inside for a day. And of course, it's going to be 60 degrees today. And you guys are all like, man, I'd rather be outside today. So sorry for that, but I can't control the weather. We are very pleased to have with us today, this is Bart Harrington. He is with YKK America, our premier aluminum provider that you all install, fabricate. He is the field technical services manager.
That's the first time anybody's ever gotten it right.
So Bart holds a very important position. He is actually, although we're happy to see him today, when he shows up to the job site, you are not happy to see him because he usually is pointing out, his job is to protect YKK and to point out everything that maybe was either fabricated wrong or installed wrong. So he knows everything there is to know about fabrication, YKK products, installation, a lot of education here, and we're very fortunate to have him educate all of you today. Some of you have sat through this class before. It's always a great refresher. You have big shoes to fill. The group yesterday was very engaged. They were awesome, provided a lot of feedback. We are also learning things that we can do as a company to improve. When it comes to fabrication, installation, Sig says often, our job is to get it done and make money, and YKK's job is to make sure it's done right and the product is perfect. So a lot of education here today for everybody, for our company as well. Bart's going to make a list for us based on your feedback on ways that we can improve. Like I said, the guys yesterday were very engaged and pointed out a lot of things. So we appreciate that because as a company, we want to do better as well. Also, Michelle Pearson is the Baltimore area sales representative. This is Jim D'Arcangelo. He is the Northeast sales representative. And this is Jim Zester. He is the branch manager for the Baltimore branch that we work very closely with. So I welcome all of you. I hope you have a really good day. We are going to provide lunch, probably about 11:45, I think, is sort of how it ended up falling yesterday. And have a great day, everybody, okay? Turn it over to Bart.
Thank you.
Thank you.
We'll see you guys later.
All right, take care.
How's everybody doing so far today? Good. Yeah, it's fun being here and seeing you guys. I was here. How many people in here have been to one of these with me before? So a lot of you have. That's good. It hasn't changed, okay? So all you have to do is remember all the things that I told you last time, and you'll be good to go this time. So like Jody said, I'm the Field Technical Services Manager for YKK AP. And actually, in this role, these days, I actually spend more time doing training than anything else. Troubleshooting problem projects is something that's not fun for anybody. It's not fun for there to be a cause for me to have to go. Usually I have to go or get involved in these things when our product is for some reason not performing the way it's expected to, right? And as you guys know, most of the time that's water leaks. But it can be other things too. It can be condensation and things like that. We're going to talk a little bit about thermal performance today too. That's one of the areas, one of the trends in our industry that's changing a lot nowadays, and that's expectations for thermal performance, and also that impacts the way we design products and can have an impact on how the systems need to be fabricated and installed. So it all kind of fits together. Just a little bit about me. I've actually been in this industry for 40 years now. I started out when I was going to college. I worked the last 2 years I was in college. I worked as a fabricator for a glass company in Atlanta, and so I've run the saw, and I've drilled holes, and I've screwed frames together and done all that stuff. And in hindsight, I wasn't doing it right most of the time. But I had a foreman who didn't like it when I asked questions, so he thought I was a smart-ass college boy and would kind of not allow me to ask questions about things. But in here today, I want you guys to feel free to question things, and if you have questions or comments about whether it's fabrication or installation procedures or even basic product information, feel free to talk about it. The guys yesterday were really great. I have enough experience and enough time where I could start talking this morning, and you guys could sit here all through today and tomorrow and through the weekend and into Monday, and I could just keep on talking. But this is generally more enjoyable for me and probably for you guys if this is as much a dialogue as it is a lecture. So please feel free to make comments and stuff, and if we get bogged down in the comments, we can always kind of keep moving ahead. But yeah, I want everybody to feel free to ask questions and make comments. So after I graduated from college, I went to work for a company called Conair. Did any of you guys heard of Conair? Worked for Conair for 16 years, left Conair and went to work for a company called Tremco. How many of you guys know Tremco, right? If you don't know Tremco, they make most of the glazing gaskets and glazing tapes and things like that. In addition to that, they manufacture all different kinds of sealants, polyurethane sealants, silicone sealants. And my understanding is you guys use both of those. You use Dimonic, which is a polyurethane sealant, and use probably Spectrum 2 most of the time. That's a silicone sealant. And so I'm very familiar with those products, and they're fine products. Left Tremco after about 2.5 years. And at the time I was working for Conair, a lot of people were leaving Conair and going to work for YKK because YKK and Conair are both headquartered in Atlanta. So there was a lot of back and forth there. And I had a lot of friends that said that YKK was a great place to work. And so I decided to change, and now I've been with YKK for, I think, I want to say going on 18 years now. So primarily in this role. So I have a lot of experience dealing with problem projects and problem products. Jody said that, when I come to the job site, I'm coming there to, be your bully. But the truth of the matter is I need to make sure that our product is being all it can be too. Not just that you fabricated and installed it right, but every once in a while we make mistakes. You guys have probably seen, and I know we've had times when things got out of our factory down in Georgia less than perfect. Hopefully it doesn't happen very often. I think it obviously doesn't happen all that often because we have a great relationship with you guys, and I think a lot of that is because our product quality is very good. But that doesn't mean we're perfect. So again, I'm not just there to pick apart your workmanship. I'm also there to make sure that our product is what it is supposed to be as well. Okay? Anyway, we're going to go ahead and get started. What we'll do today, everybody's got a booklet in front of them that says Quality Education and Training. Those booklets are yours to keep. You can use the pens. I think they've got pens and highlighters there for you. Feel free to, basically what we're going to be going through in the book are the fabrication and installation instructions for these products. Feel free to make notes, highlight things, whatever you want to do. You'll also notice that the very last tab in the book says notes on it. That's lined pages for if you want to write down notes and things like that. And again, like I said, we're going to start with storefront installation. And then, again, as I said, if you have any questions or any comments, feel free to raise your hand or speak up, and we'll move through this stuff. Yesterday, I want to say we got finished at about 3:45. I'm kind of aiming for the 3:30 time frame. So just so you have an expectation for when we might be finishing up today. Okay? Let's learn. Okay, so what we're going to talk about first is our storefront product. This is probably our biggest selling storefront product, YES45TU. That's the name of the product. Does anybody know what YES stands for? It's an acronym. It's not the word yes. It's an acronym. Does anybody know what it stands for? Nobody? Anybody want to take a guess? What does the Y stand for? There you go. Anybody know what the ES is? Entrance system. Yeah. So we kind of refer to all of our storefront systems as entrance systems. Storefront systems are designed to be used in ground floor applications. If you want to look at what our engineers are designing storefront systems, what kinds of projects they're to work on, just think of your typical strip shopping center. You know, you drive by, there's a tattoo shop, a place to get your nails done, maybe a little restaurant or something in there. And what you have is the fixed glazing, and you have operable doors, which are part of the storefront framing. And so when you look at what storefront systems are, what they're intended to be, they're intended to be used for those kinds of applications, single-story ground floor applications. So that's the YES45TU is a YKK storefront system. What about the 45? Yeah. So whenever you see in our parts, or our not our parts, but our product names, whenever you see any kind of number, typically it refers to some nominal system dimension. Okay. In the case of this system, the front to rear, from the very front of the vertical mullion to the back of the mullion or horizontal mullion, it's 4.5 inches, hence the 45. What does the T stand for? Thermal. Yeah, that means it has some added feature to it to enhance the thermal performance of the product. So our products are all made out of aluminum, which is thermally conductive. Okay, and one thing that is often required on projects, especially up here, is some type of enhancement to the product to slow down the thermal transfer between the outside and the inside, right? And so that's what the T stands for, is that there is some feature that we're adding to the product from a manufacturing standpoint to improve the thermal performance because aluminum is so conductive, okay? What about the U? Anybody know what that is? Unit? Good guess. That's not it. Okay. What U stands for is urethane. So in the case of this product, this particular product, we have, by the way, in terms of thermal performance, we have different ways of doing that with our products. The way that we do it with this product is with a liquid polyurethane. And so when we extrude the mullions, and do you guys know how, by the way, do you know how we make the aluminum mullions? Anybody know how we make them? Yeah, they're extrusions. Do you know what extruding is? The Play-Doh Fun Factory. Do you everybody play with Play-Doh Fun Factory when they were a little kid? Right? You put the Play-Doh in, you push the thing down, you push the lever down, and the Play-Doh kind of oozes out the other end in whatever shape. You know, there's a die there, sometimes in the shape of a star, sometimes it's a circle, sometimes it's a square, and the Play-Doh extrudes out in whatever that shape is. That's how we make these aluminum mullions. Okay. Obviously, it's not some guy with giant forearms pushing a lever down. Okay. There's machinery that does this. We heat the aluminum up to a very high temperature to make it very soft, and then we have dies, and the extrusions come out. Well, the way the polyurethane thermal break works is one feature in the extrusion that we produce. There's a little channel that runs right down the middle of not in the middle of the glass pocket, but in the glass pocket. And after we extrude the aluminum, we take and after we finish the aluminum, paint it or anodize it, we take it over to the thermal department, and they pour liquid polyurethane into that channel. And then they debridge the underside of the channels. Have you guys ever heard the term pour and debridge? That's what that is. They're pouring liquid polyurethane into the aluminum channel, and then they're debridging. After the polyurethane cures and hardens, they debridge the underside of that channel. That's the sharp thing that you don't ever want to run your finger along when you're handling the metal. Okay, so that's what the TU is. It's a thermal enhancement to the product, and in this particular case, we're using polyurethane, YES45TU. Okay, And these are these are the basic system details. So what you're looking at here is your jam condition. Here's our 4.5 inch deep mullion. It's a flush glaze system. So what are the two things you have to have in a flush glaze storefront system in order to physically be able to get the glass into the glass pocket? There's two features the system has to have. You know what they are? Well, you have to have at least one deep vertical pocket. You'll notice here on one side of the mullion we have a shallow pocket. So that means on the other side of this lighted glass there has to be a deep pocket. So you have to have at least one deep vertical pocket, and then you have to have at least one removable glass stop per light to physically be able to set the glass in. So you can see here the jam mullion has a deep pocket. The next vertical also has a deep pocket, but then a shallow pocket. And so they alternate as you go all the way down the storefront. Usually at one end or the other, you'll have two deep pockets facing each other. Okay? What's this thing right here?
Thermal break.
Not this, but this. That's the thermal break. Okay? So I'm showing it in red here, but what color is it really?
Black.
Yeah, it's black. So this is the channel. So again, when this is a 24-foot long extrusion, the bottom of this channel, this channel right here, is still intact. And again, we pour the liquid polyurethane in, and the liquid polyurethane is real high in solvents. It's basically remaining a liquid because it's in solvents as it's stored. When it reaches the atmosphere, the solvents immediately flash off, and this cures and hardens almost instantly. Okay? So then once this is cured and hardened and bonded to the aluminum, we de-bridge the underside of that channel. And you can see that in the other half of the vertical mullion, and the sill flashing, the sill, the intermediate horizontal, and the head member. Okay? And then, of course, these are the glass stops. Notice we have glazing gaskets inside and out. We use a common gasket. It's the same gasket inside as we're using outside with this system. The gaskets are made out of, does anybody know what the gaskets are made out of? Rubber? It's a rubber-like material. It's actually made out of a rubber compound called EPDM. And EPDM, the reason we use EPDM is because it's compatible with silicone, and more we're seeing people use silicone sealants, and so that's why we use those types of gaskets. And like I said, it's a common gasket, so we use the exact same gasket on the outside that we use on the inside. Okay. We'll talk more about how all this goes together as we go through this. Excuse me. But does anybody have any questions about these basic details before we move along? Okay? You'll be seeing some of them again as we go through this. Okay? Now, if you open up your book, you'll see we have an installation manual. And the first thing I want you to notice is at the very bottom of the manual, there's actually a publication date. Not the actual date, it shows the year on the front page. It says 2024. The reason I'm kind of pointing that out is every once in a while we make changes to the installation instructions. Now the changes might be relatively minor, like somebody finds a word misspelled or something like that, but every time we amend it, if the marketing people go in and fix something that's wrong in the installation instructions, or if we make a change to the product, we have to republish the book. So this one was actually done, and on the next page you'll see, I think it has the actual date that it was done. April 5th, 2004 was the last time we actually made a change. And like I said, it might be something as simple as a misspelling, or maybe we add a detail or an isometric view to improve the understandability of the document. Sometimes we change part numbers on things because maybe we change from a zinc-plated screw to a stainless steel screw, which leads to a part number change. And when we do that stuff, we have to change everything. But the reason I'm telling you this is because it's very important whenever you're working on a project that you're using the most current version of this instruction, okay? Anybody, and by the way, these instructions are available on our website. Anybody can go to our website and download a copy of these installation instructions. So again, don't be surprised if you're on a job site somewhere and an architect is walking around looking at what you're doing with a copy of this. Because like I said, it's not a secret document. It doesn't require a password to get access to it. Anybody can download it and print it off. Okay? And I would, our preference is that you not keep old copies of these under the front seat of the truck. What we want you to do is whenever you're doing a project, make sure you have downloaded and you have the most current version. And when I say you, I don't mean it's your responsibility to do that, but you can certainly ask your project manager here at South Jersey Glass, if you don't have the most current set, to give you a more current set. Okay. On this page right here, this page is called Installation Notes. Most of it is common sense stuff that do we really need to be told. So for example, this first item here, do not drop, roll, or drag boxes of aluminum framing. I don't think you guys need to be told that, do you? No? Yeah, you don't. Yeah, you need to kind of handle it with care. We don't want to get it damaged, okay? But there are some items in here that are kind of worth talking about as we get started. The first item is, if you take a look at item number 7, it says, make certain that material samples have been sent for compatibility testing for all manufacturers' sealants involved. Make certain sealants have been installed in strict accordance with the manufacturer's recommendations and specifications. Let me explain how that pertains to you. As we go through these installation instructions, we're going to see things like you need to make sure you seal this, and don't forget to seal that, and put sealant on this. There's a lot of that in here. But one thing we don't tell you is what kind of sealant to use. Just from talking to the guys yesterday, they mentioned Dimonic and Tremco Spectrum 2 as sealants you use, but there's other ones that you may use from time to time as well. And there's usually various reasons for why certain sealants are used on a project versus other sealants. And we don't often know what that is. We're providing you with the material. You guys are the ones that are integrating it into the construction that's going on. So sealant selection is generally left up to whoever is doing your shop drawings and the architect usually, okay? And so we don't know what that is. And so the bottom line is that the sealant, for the sealant to work, it has to stick to the metal, correct? Right? So it's very important that you're following the sealant manufacturer's recommendations for cleaning the metal, okay? Now, where's the saw guy? Okay, Lewis, right? I heard him mention your name. So on that saw down there that you work on, do you guys have lubricant they spray on the blade?
Yeah.
There's like a mist?
I don't know.
Okay. So what that's for is to keep the saw blade cool so that it stays sharp longer. If you didn't do that, it'd get clogged up with aluminum chips and you'd have to be sharpening the blade all the time. So they use that, and it's important. But do you think that stuff, that mist that's on the aluminum when you cut it, do you think that promotes good adhesion for the sealant? No, it's not going to want to stick to that. So whenever we talk about applying sealant onto anything, there's a certain amount of cleaning that has to occur first. Now, does anybody here work in the fab shop assembling frames here? You do? Do you guys clean the material? Do you wipe it off?
When you need to
apply sealant? Okay.
Yeah.
What are you typically using to clean the metal?
We have different alcohol.
Alcohol? Okay, good. Yeah, typically if you're using silicones, they're going to want you to wipe it down with isopropyl alcohol. Okay, not so much the denatured alcohol. Some of the guys yesterday told me they do denatured alcohol and then they do, isopropyl alcohol. Whatever. I think typically they want you using isopropyl alcohol. Does anybody know what denatured alcohol is? It's alcohol that has something added to it. And why do they add something to it? You're smiling like you know. You don't know? You just think it's a weird thing to talk about. Okay. So denatured alcohol means that they've added something to the alcohol to make it taste bad. That's what denatured alcohol is. Otherwise, you can mix it with grapefruit juice or something. But they put the denatured alcohol The denatured alcohol, they put something in it to make it taste bad. That's literally what it is. The problem is that different manufacturers use different things that can affect how well your sealants stick. That's why the sealant manufacturers that do silicone want you to use isopropyl alcohol for cleaning the metal. Okay, and that can be not just for in the shop for removing the lubricant that sprays on the metal when you cut it, but also in the field when you've got to apply sealant in the field and you've got dew on the aluminum, right? You know, the thing is you can wipe it with a rag. That tends not to, help too much with getting the metal dry again. Whether it's dry or whether it's wet because of the dew or because it's been raining on the job site, you have to get the metal dry before you put the sealant on. And again, isopropyl alcohol is very good for that because it's water soluble. So if you have a rag with isopropyl alcohol, you wipe it on the water, it causes the water to evaporate much more quickly. Okay, so that's a good thing to know. On the other hand, if you're using polyurethanes like Dimonic or something like that, you might be better off just using mineral spirits. But again, I'm just telling you that information more, not so much that you'll remember the specifics of the cleaning materials and the sealants, but that it's important to clean them, and that it's important to make sure that you're doing it in accordance with whatever the sealant manufacturers wants you to be doing. Okay. There are exceptions to us not telling you what kind of sealant to use. So, for example, if you guys looking for a seat?
Yes, sir.
I think are these end seats here? There, see, I think you guys get the it's like the last guy that gets into the loaf of bread and you got to eat the heel, right? You got to eat those. You guys are sitting on the heel of the table there. Where we have. Have you guys ever done a splice in your sill flashing before? We're going to talk about that. We actually use a cured silicone sheet as a splice sleeve, and for that reason, you do need to use silicone sealant where you're putting those splice sleeves in. Okay, it doesn't mean you have to use silicone everywhere, but at that location, it's necessary because the silicone will only really work well with silicone sealant. Okay, the other exception would be. And I'm not sure how much of this you guys do. If you're ever installing a hurricane impact system, we do have specific guidelines for which silicones to use for those because there are a lot more things going on than just air and water infiltration with those systems. Okay. Item number 8, it says, remember to isolate in an approved manner all aluminum from uncured masonry or other incompatible materials. Okay, what do we mean by incompatible materials with aluminum? What do you think they're talking about there? Do you guys know of any material that's not compatible with aluminum?
Salt.
Salt? Okay, good. Salt's a good one. Steel, most definitely. What else?
Concrete.
Yeah, uncured masonry, concrete, things like that. What about treated lumber? Yeah, none of these things react well with aluminum. Aluminum and steel in particular, aluminum and steel are what they call dissimilar metals. Okay, aluminum is what we call a non-ferrous metal, meaning it doesn't have any iron in it. Okay, what's steel made out of? Steel's made out of iron. So in the science of metallurgy, there exists something called a galvanic chart, and all of the metals are listed on that chart by order of their potential for galvanic reactions. And the further apart two metals are on that chart, the more likely there is to be a galvanic reaction if they come into contact with each other. And so steel and aluminum are very far apart on the chart, so we have to be concerned about that. So how does that impact all of us? Well, have you guys ever had to put steel reinforcement inside of aluminum mullions? Yeah, we have to do that every once in a while. And so it's very critical that the steel not be in direct contact with the aluminum because of the potential for something called a galvanic reaction. Or the guys yesterday, some of them referred to it as electrolysis. And that's an apt description of what's going on. It's an electrochemical reaction that occurs when the dissimilar metals come into contact with each other. And usually there is some other catalyst involved in accelerating that and a good example would be, and I know you guys have seen this before, where you have a door jamb sitting down hard on concrete, right? And then what happens in the wintertime up here? Yeah, you get ice, and the concrete gets wet, and then they put either salt or some other type of de-icing chemicals down there. And what effect does that have on the bottom of the door jamb? It starts to corrode it, doesn't it? Okay. One thing that we like about aluminum is typically it's not corrosive. But if you put it in contact with something that it's not compatible with and add a catalyst to the equation, then we have corrosion. And so by sliding that steel inside the aluminum, we have the potential for a galvanic reaction. That's why whenever you put steel inside of the aluminum mullions, you need to make sure that you're coating the steel before you slide it in there. Okay. Now, if you're using steel that we send you, it's going to have a coating on it. Do you guys use the steel that we send? It's kind of got like a gray paint on it. Sometimes. It better, if it's coming from us, it better have it all the time.
I'm saying we use your steel.
You use our steel sometimes. That's a good answer. So yeah, so if you're getting the steel from us, it's already got the coating on it. But then you have to do what? You have to typically cut the steel, don't you? And what I'm telling you here is that you need to make sure that you're coating the cut ends of the steel as well. Okay? So you should have, it doesn't have to, it's not anything special. It can be any type of zinc chromate or bituminous or even just primer, rust inhibitor for steel. Anything that prevents the steel and aluminum from coming into direct contact with each other. Okay? So that's the easy part. Okay? The other part is what goes around our framing system? Steel, wood, concrete, right? We're installing into those materials all the time, all day, every day. So do we want the framing coming into direct contact with those? No, we don't. So what do? We make the frame a little bit smaller than the rough opening, and we shim, right? And there's actually a couple of reasons that we do that. One is to prevent those incompatible materials from coming into contact with each other. The other reason is because our frames always have to be installed plumb level and square. Okay? And the reason that they have to be installed plumb level and square is because they're internally drained, meaning that if water gets inside the storefront system, it has to be able to drain out. And if your framing is not installed plumb level and square, then the water may not want to drain out, and you have water sitting inside your system for a long period of time. Okay? So we always have to take the rough opening dimension and deduct from that to determine our actual frame sizes. And then the shims, in addition to us allowing us to install the frames plumb level and square, it's also insulating our aluminum from those incompatible materials. Make sense to everybody? Okay? So again, the frames have to be installed plumb level and square. We'll also talk about door installation today. Doors obviously have to be installed plumb level and square. And I'm not going to go through all of this stuff. The books are yours to keep. Tonight when you get home, as homework, I'm going to assign you to read this whole book cover to cover. And you can do it or not. Okay? The next few pages, I kind of call this the parts identification section. If you look here at this page 1, the first items here, probably the first 1, 2, 3, 4, 5, 6 items. If you look at that, you have the mullion or the mullion / jamb, the head mullion jamb, the horizontal, the sill, the glass top, the sill flashing. You probably see all of those on every project you do with this storefront system. Okay, but then there's some other ones maybe that you see less often. Okay, and so we have this in here. So as you're opening boxes, you're getting material. If you see things that you don't know what they are, if you have this booklet handy, you can look in here and go, oh, this is a head receptor, or this is an expansion mullion. Okay, you guys know what expansion mullions are? If you don't, you're going to in a few minutes because we're going to be talking about them. Okay, so again, this is sort of a way for you to identify the parts and pieces, especially the ones that you're not accustomed to seeing on a regular basis. Okay, and that becomes especially important when you get into the accessory parts and pieces, right? Like here on page 3 and page 4, We have things like end dams and setting blocks and these little flat filler pieces and W side blocks and water deflectors. And look at this, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different kinds of fasteners that might be used with this system. So you guys get the truckload of material. It's got a bunch of long boxes on it, right? That's your stock lengths. And then there's usually a pallet or maybe some smaller boxes, right? You open up that, and there's bags of screws and plastic parts and pieces and all that stuff. And again, if you open those, and obviously they all have a purpose, or you guys wouldn't be buying them. And what we don't like to see happen is you guys get finished, fabricating and installing our system and having all this stuff left over because you didn't know what it was for. Okay, kind of like if you go to Home Depot and buy something that you have to put together. Like I like putting stuff together. I don't like to buy the one that they put together. I like putting it together myself. But I always read the instructions. Some people don't. And so they don't understand why the igniter on the grill isn't working, right? But they've got bags of parts and pieces sitting there and they don't know what they are, right? Same thing. We just want to make sure that all the parts and pieces are getting left over. And if you've got a bag of parts and pieces and you don't know what it is, look it up here, and it actually has a little description of what it is and what it's supposed to be used for, okay? So again, our idea here with the installation instructions is, again, like our material has the potential to perform properly, but we require you to fabricate it and install it properly. These instructions are here to ensure that you guys know all the things that need to be done to make sure it can be done correctly, okay? So here on page 5, this is showing you how we arrive at the calculated dimensions for how long we cut the verticals and how long we cut the horizontal mullions. Okay, so this is showing a diagram of the rough opening that we're going to be installing our storefront framing into. And what this is showing here is measuring horizontally at multiple locations and arriving at you're going to use the least of these measurements, measuring horizontally, and that's going to be what your rough opening width is, okay? We have to then deduct from that to determine how wide the frame is going to be, right? And the reason we have to deduct from that rough opening width is because we have to have room for shims and perimeter caulk beads and things, like we've already talked about, okay? So we're going to take the minimum rough opening width and we're going to subtract 3/4 of an inch. One thing that we require is a minimum 3/8 inch perimeter caulk bead around this frame. Okay, 3/8 of an inch above the head, 3/8 of an inch at each jamb, and 3/8 of an inch underneath the sill flashing. Okay. When it comes to that 3/8 of an inch, and by the way, one other thing, when we go through the installation instructions, we're going to talk about, prep locations and fabrication requirements and things like that. Nothing in the installation instructions is random. There's a reason for everything in there. So what is the significance of the 3/8 inch perimeter caulk bead? Does anybody know? Why 3/8 of an inch? Why don't we say 1/8 of an inch? Or why don't we say, 2 inches?
Expansion.
Because the depth of the caulk is determined by the width of the joint.
Yeah, there are, again, most of it is not related to the framing itself. We do require the caulk beads, obviously, to keep air and water from flowing around the frame, right? But we don't require the caulk beads for any performance reasons other than controlling air and water. But when it comes to something like a perimeter caulk bead, the sealant manufacturers view that perimeter joint as being what they call a dynamic joint. A dynamic joint is a joint where they expect that there is going to be differential movement of some kind, and the sealant needs to be able to stretch. Okay? The sealant needs to be able to stretch. That's what's important. What causes that movement? Usually with storefront framing, it's expansion and contraction. Okay? Aluminum as a material is almost ideal for what we want it to be. Like I said, unless there's a catalyst and a incompatible material with it, aluminum doesn't corrode. An example of what I'm talking about is when I was a little kid, and if anybody I don't think we have anybody else here old enough to remember this. Beer cans now are made out of aluminum, aren't they? They didn't used to be made out of aluminum. They used to be made out of steel. Okay? And you would, playing in the woods as a little kid, you'd find an old beer can laying there. And what was it? It was just like all rusty, and you could pull it apart with your hands. Now you can find an old beer can in the woods, and maybe the Budweiser paint's faded off of it, but it's still otherwise in very good shape, right? So aluminum is real good about lasting, even if it's got water on it, and that's one of the reasons why it's ideal. Like my house that I live in, I have wood windows in my house, and so we have to paint them every so often. We got to repaint them. Do you have to repaint aluminum? Not if you got a decent anodized or painted finish on it to begin with. You should be good to go for 20 or 30 years, right? And speaking of 20 or 30 years, does anybody know how long our warranty is?
15, 20.
No? 1 year.
1 year.
Yeah, our standard out of the box as manufactured. Now we have extended warranties, like we have a lifetime warranty on the door corner construction, and we have extended warranties on some of the finishes. But on the actual material, our basic product warranty is 1 year, which is, by the way, probably the same as what your basic warranty is. When you guys do a project, South Jersey Glass writes a warranty letter, and they give probably a standard 1 year warranty, unless the building owner requests something longer than 1 year. Okay? Now, we the same, which is the same for us. Sometimes they request a 5 year warranty or a 10-year warranty, and we have to decide if we're going to do that, if we're going to charge extra for it, and all that stuff. But my point here is that since we're only putting a 1 year warranty on it, does that mean that the aluminum is going to change somehow or stop working after 1 year? Okay. How long, if we manufacture the aluminum properly and you guys fabricate it and install it properly, how long do you think is reasonable for an owner or an architect to expect that aluminum framing system to perform under normal conditions without there having to be any major repair or replacement work other than maybe washing it every once in a while? How long is reasonable to expect? 25 years? Does that seem like a long time, 25 years?
Caulk will fail first.
What's that?
Caulk will fail first.
Well, maybe the caulk will fail first. That's part of the problem with polyurethane caulking. Yeah, you won't get more than a 5 year warranty on polyurethane caulking. So yeah, if they've got polyurethane caulking, that'll fail before anything else. But that's one of the reasons people are going more to the silicone caulking, because silicone is chemically inert and it'll last as long as you guys are putting it in properly and doing the caulk beads right. It'll last a long time too. Okay. My point is, though, I don't think it's unreasonable to expect this stuff to last 25 or 30 years. And that's, again, one of the good things about aluminum. One of the bad things about aluminum that we already talked about is it's thermally conductive, right? But we have thermal breaks to deal with that, correct? Now, in terms of the other thing that's not good about aluminum is it expands and contracts a lot when you get changes in temperature. You guys know how that happens, right? Who remembers their 5th grade science class where you learned about molecules? Molecules, you guys remember them? Okay. So everything consists of molecules, and they're chemically bound together, but they're constantly in motion. Okay, they're at a microscopic level, they're constantly in motion. When it gets very, very hot, the molecules are getting a lot of heat energy, and they move faster. When it gets cold, the molecules are getting less energy, and they move slower. The effect that creates is when it gets hot and they're moving faster, in order to accommodate that added speed of the molecules, things expand. And when it gets cold and they're getting less energy, things contract. Every material that you know of does that to some degree, okay? And it's a measurable amount of movement. Aluminum happens to do that at a very high rate, okay? So how high a rate is it? Well, as an example, if you have a 10-foot long piece of aluminum and you change the temperature of the aluminum by 100 degrees, it will change in length by 5/32 of an inch. 10 feet. So how far 24 feet is going to be like 5/16 of an inch. So think about that for a minute. Now, is 100 degrees a lot? Do you think 100 degrees is do you think that's an unreasonable expectation for temperature change in aluminum? It's okay to guess. No, you don't think it's a lot? You guys ever picked up a piece of bronze anodized aluminum on a sunny day?
Yeah.
Or tried to pick one up with your bare hands on a cold day, right? You got wind chill factor, right? You got humidity, and you get a little bit of moisture on the aluminum, and you blow some wind over it when it's real cold. It's like refrigerator coils, right? So 100 degrees change in temperature is really nothing. So the aluminum is going to expand and contract, okay? That's a bad thing about aluminum. But as long as we know that it's going to do that, and we can design fabrication and installation procedures to account for that expansion and contraction, we're going to be okay. One of the things that we have to be aware of is that that's going to have an impact on our caulking, okay? And again, if you're not doing your caulking right, that can lead to the sealant tearing. And if your sealants tear, then you don't have the air and water control around the frame that you need to have. And so that's why, a lot of times we run into situations where people, instead of shimming the sill flashing up, what they want to do is dump a whole bunch of sealant on the ground and bed the sill flashing in sealant. And when you install the sealant in that manner, you're eliminating its ability to stretch. So what do you think when you bed that aluminum sill flashing in sealant on concrete and the aluminum wants to expand and contract, what's going to happen to the sealant? It's going to tear, okay? Or it's going to lose bond with the concrete, or it's going to lose bond with the aluminum. In any case, your weather control has failed at the perimeter of your frame, okay? That's another reason we want to make sure we're shimming this up to accommodate that thermal expansion and contraction, okay?
You say sill flashing, talking about subsill?
Subsill, yeah, I'm sorry. I'm backing up a couple slides. We were talking about the names of these things. It's funny, I go to different parts of the country and do training, and there's a lot of things like this. Yeah, when I say sill flashing, if you were to look in our parts list and our installation instructions, we always refer to this as the sill flashing. I know, especially around here, you guys tend to refer to it as sub-sill, which is the same thing. Okay, we call it sill flashing, but it's often referred to as sub-sill. It's like a door. In a door opening, the very bottom part, we refer to it as a threshold. Some people call it a saddle. Okay, same word, same thing, just different words.
Slow than a hood.
What's that?
It's a little slow than a hood.
Yeah. Okay. So again, we have to reduce the size of the frame to fit in the rough opening. Again, to allow us to install the frame plumb level and square. Why does that allow us to do that? Do you ever get an opening on a project that is plumb level or square as provided by the general contractor? Never. It's never level, it's never plumb, it's never square. So but since the frame has to be installed plumb level and square, we must reduce the size of the frame so that we can use shims to make up that difference and allow us to anchor the frame in a way that it can manage water and that we can successfully caulk it to last for a long time. Does that make sense to everybody? Okay, good deal. You guys ever install your storefront frames using receptors like this? Okay, so this is a recent addition. We didn't used to have this information in the installation instructions. I know that you guys have a small percentage of projects where you do this. I'm not going to spend a lot of time talking about these receptors unless you have questions about them. We can talk about them. But again, these are often used in cases where maybe they expect there's going to be structural movement up above the storefront frame. Normally what we do is we have a pocket filler in here and we have a shim and we're anchoring up hard to whatever structure's up above there. And if the structure moves, there's no accommodation for that movement. It can cause it can crush the top of the storefront frame. But if they expect that there's going to be some type of structural movement up above here, this allows the structure to move up and down, and the receptor can kind of slide up and down on the top of the frame to accommodate that movement. Other reasons it might be used is if you have a whole lot of frames and a whole lot of openings, and they're all going to be they're all going to be constructed to different dimensions. Instead of they're all supposed to be 4x4, they might be plus or minus a half an inch or an eighth of an inch or something like that. We can often still build all the frames the same size and allow the receptor to accommodate whatever construction tolerance differences there are. Okay, so these get used, and so of course we've got instructions for how those need to be anchored and installed as well. Okay. Another thing I wanted to point out back here is if you have a storefront frame, let's say this entire wall here is going to be a run of storefront, okay? If you have a run of storefront that's over 24 feet long, you need to have expansion mullions every 12 to 15 feet in that run of storefront, okay? So this opening here is certainly longer than 24 feet. Why do we need expansion mullions in the storefront? Yeah, expansion and contraction. We've already talked about the fact that the aluminum wants to expand and contract. So let's say we install this, and let's say this is on the south side of the building, okay, and you're installing it in the winter time, okay, where it's real cold outside, and you install your storefront. You don't have any expansion mullions, and then what happens to that aluminum when it gets hot outside? So the aluminum is going to want to expand, right? So in a run of storefront, if you're not allowing expansion, what kinds of bad things can happen to that storefront?
Filling, glass break.
Not so much glass breaking. What you're going to see,
If you have racking.
you might have some racking. Now, on the conversely, if you're installing the storefront when it's very, very hot outside, okay, and it gets cold, where the mullions all want to shrink, sometimes that'll cause the mullions to unsnap. Now that's not a good thing, is it? The two-piece vertical mullions unsnapping, that would be bad. But in a long run of storefront like this, you're typically going to have doors in it, right? You guys ever have doors that are they bind on the frames? Okay. What can happen is if you have a horizontal in this storefront, by the way, what a typical storefront? How tall is a typical storefront?
10 foot. Less than 12.
Yeah, less than 12 feet or less typically. And typical opening would be maybe anywhere from 8 to 10 or 12 feet tall. What about the spacing between vertical mullions?
Typically less than 4 feet.
4 feet-ish, something like that maybe. 4 feet plus or minus these would be typical applications. So is that 4 foot long horizontal, is that going to expand enough to create a problem? Just a 4 foot horizontal? No, but typically the horizontals are between the vertical mullions, but the horizontals are running the entire length of the storefront except at the doors, right? So you may have a 4 foot horizontal here, and then a vertical mullion, and another 4 foot horizontal, and this goes on until you get to a door jamb. Well, each one of those 4 foot horizontals is going to expand a little bit. By itself, that doesn't mean anything. But when you add it all up, that means something somewhere has to give. Now, can the aluminum horizontals expand in this direction? A little bit, maybe if you've got a 3/8 of an inch caulk joint, okay? What about as you go this way and you come to a door jamb? What do you think happens with the door jamb? It's going to tighten it up. It's going to bow it into the open. So what we want to make sure we have is a vertical mullion that allows for expansion and contraction when you have these long runs of storefront, okay? What that does is it prevents the vertical mullions from unsnapping from each other. It prevents the door frames from bowing in, affecting the operation of the door, or maybe even the securing of the door, right? Sometimes you guys have doors with latch locks or concealed rod panic devices where you have to adjust the door to get it to lock, right? What if expansion and contraction changes your door opening and now the door won't lock, okay? So we have to have the expansion mullions in there to prevent the unsnapping of the vertical mullions when it gets cold. It also takes the stress off the perimeter caulk beads, and it allows our door frames to stay installed square. So again, a run of storefront over 24 feet, we want expansion mullions every 12 to 15 feet, okay? Most of the time you guys are doing screw spline fabrication, right? That means you got a 2-piece vertical mullion that snaps together. You're building the storefront framing in sections, taking it out to the job site, and snapping it together. What this is showing are the layout dimensions for the vertical mullion hole preps that have to be drilled in the vertical mullions for screw spline attachment of the horizontal mullions. That's all this page is showing, is what the layout dimensions for those preps are. My understanding is you guys have CNC equipment that does all that, correct? So this kind of information would be programmed into your CNC equipment so it knows where to do the preps based on where the projected horizontal mullion locations are going to be, okay? And this is just a sort of I kind of blew it up and colorized the view so you can see. And you'll notice here that for outside glazing, this is your, again, what we're looking at is the outline of the vertical mullion. And this is showing how at the sill and the horizontal, the attachment hole preps are staggered up and down, with up being on the inside and down being on the outside. And at the head, they're even. Same thing on the pocket filler preps. They're going to be at the same locations on the pocket filler. Okay. Glass stops. Do we cut the horizontal glass stops the same length as the horizontal mullions?
Well, technically.
What's that? You do? Technically you do? Okay, that's an interesting addition. Okay, should we cut the horizontal glass stops the same length as the horizontal mullions? Okay, no. Why not?
Because you need to slide it in there.
Yeah, there's the horizontal mullion, or the horizontal glass stop, is installed into the frame after the glass is set. And in commercial glazing, usually they're setting the glass in the fields. We have a couple of YKK employees here. You work for Pella, right?
I did.
Okay. So typically in the residential window business, the glazing's done in the factory. Whereas a lot of times for our stick-built products, the glazing is done in the field. And so that means that they have to be able to snap the glass stop in the field. So what we typically do is we cut the glass stop just a little bit short of the length that we cut the horizontal mullion, so that it makes it easier for the guys in the field to rotate that glass stop into place and snap and gauge it without doing what to the vertical mullions? Without scratching. Okay, so that's the theory, right? And that's what should be done. But every once in a while, if you have a rookie fabricator like I was at one point, I'm thinking, why can't I just snap the glass stops on and cut them the same length as the horizontals? And then the guys from the field come in and go, who the hell cut these glass stops? And then I had to own up to it because I didn't know any better. I was ignorant, okay? But we want to cut the glass stops a little bit short. How short do we cut the glass stops?
30 seconds.
Okay, 32nd of an inch. Is there anything specifically significant about a 32nd of an inch?
No.
Not really, okay? What we want is not only for the glass stop to be easy to install, but we want it to look good after it's been installed, okay? So we could, in theory, cut the glass stop 1/8 of an inch shorter, couldn't we?
No.
We could.
Wouldn't
Look very good. You think the architect would like that? He would not like that, okay? And I would also venture a guess that maybe cutting an eighth of an inch short might actually impact the performance of the system, because we measure air and water infiltration into these things, okay? And certainly by cutting the glass stop that much shorter, you might potentially be inviting more air and more water into the system than we want to have coming in. So there becomes a point where between a 32nd of an inch and an 1/8 of an inch where you have performance-related issues potentially, okay? So, but still, what can happen is, let's say you cut it to DLO minus a 1/16 of an inch. Is that a problem? Probably not from a performance standpoint, but is the architect going to like the way it looks? I can't make the architect like that. So this is a common thing that happens. I get this phone call all the time. Hey, Bart, we've got an architect. Your installation instructions say to cut the glass stop a 32nd of an inch short. Our guys cut it a 1/16 of an inch short. Mea culpa, shame on us, all that good stuff. Could you please write a letter to the architect telling him that that's okay? Can I do that? That's probably not a good idea. It's not a good idea for me to write letters that contradict anything in our installation instructions, unless you have a very good reason for needing to cut it shorter than a 1/16 of an inch. Like, let's say, for example, let's take this storefront opening right here, okay? Just as an example. We have 3 bays in that. So how many glass stops are in that? 3. Each one of those should be cut a 32nd of an inch short, correct?
Yeah.
Okay. What if, instead of having those 2 vertical mullions in there, we didn't have any vertical mullions? Let's say we were butt glazing that, and we had 1 glass stop that went along that entire length. Okay? 1 glass stop. How long? I don't know how long that is. How long is that? 18 feet, something like that? Okay? And let's assume also it's not inside. Let's assume it's outside. Now let's talk about expansion and contraction of that glass stop. Might it be worthwhile to cut it more than a 1/16 of an inch short because of expansion and contraction? Yeah, I think a 32nd of an inch on a 6-foot long glass stop is not a big deal. But a 32nd of an inch on an 18-foot long glass stop might be a problem. So there are times where you may, so like I said, if you've got a condition where there is a logical reason besides not paying attention to the instructions or workmanship, then we can work with you on situations like that, okay? But again, that 32nd of an inch, and again, that said, I'm going to give you some advice, and you can take it for what it's worth. Let's say that these guys in the fab shop out here cut it a 1/16 of an inch short, okay? And whether you know that it's the wrong size or not is not the point. But typically, when these guys snap the glass stops in, what the architect sees, what he doesn't like, is when he's got a hairline joint on one side and you've got the full 1/16 of an inch on the other side. You see what I'm saying? If you center that glass stop when you put it in, if that's the case, try to eyeball it and get it to where it's even on both sides, and they probably won't even notice it. And it probably won't be a problem. Obviously, my first preference is that you cut it to the right size, but if you don't, make sure that you install it in a way that's not going to draw attention to it. But then make sure you do it right the next time, okay? And I know that would never happen to you guys, right? Okay, the actual sill fabrication. So the sill is also going to be cut to the daylight opening dimension. We have a way of attaching our sill to the sill flashing in a way that does not require any further penetration to the sill after the sill's actually been anchored, okay? Have you guys ever seen where the screw goes through the back of the sill flashing? I know you guys would never do that yourselves, but you guys have seen that before, right?
Collier.
Actually, not. You can't blame that one on Connier. Okay. What Connier shows, and what we used to show, is what we have to be worried about here at the sill is something called an end reaction. Does anybody here know what an end reaction is? Okay. I think you probably do. You probably just never heard it called this before. Do you know what deflection is? Okay, so these framing systems, they can be fairly tall. And when the wind blows, the glass catches the wind, and it transfers the force of the wind to the mullions. So the mullions are what's kind of holding everything together when the wind is blowing, okay? When that occurs, when the load is transferred to the vertical mullions might want to bend a little bit in reaction to that wind. You follow me? And that's okay as long as it's a minimal amount. And typically in our industry, we have a standard. It's a deflection, maximum allowable deflection, and it's actually a ratio or a fraction. That actual number is not what's important. What's important is what's going on when it's happening. So so if the wind is blowing, the glass catches the wind, and in reaction to that force, the mullion might want to bend a little bit, okay? And as long as that bend is minimal, and these are all engineered expectations and things like that. That's why sometimes we have to put steel in the mullions, okay? When we think the mullion is going to deflect too much by itself, we put steel in it. or we use heavy mullions. We use heavy wall mullions. But that's what the deflection is. So now let's take that and look at the practical application of it. So let's put some sawhorses right here on the floor, and we'll put a 2x4 on it. Pretend the 2x4 is your storefront mullion. When you press into the middle, on the middle of that 2x4, what does it do? It deflects. What happens at the ends?
The opposite direction.
They go in the opposite direction. That's an end reaction. Okay? So when your storefront mullion, when the wind is blowing and your storefront mullion is deflecting in that direction, what's happening at the head and the sill is an end reaction in the opposite direction. You follow me? Okay? So the reason that we're anchoring the bottom of these things the way that we are is because what we're trying to prevent is we're trying to prevent the sill from reacting outward. Okay? And so what's preventing that, what's preventing this sill from reacting outward are these screws right here. Okay? See that? This little screw right here? And that's what this prep is for right here. On the horizontal mullions, this little channel out here in the front, you're going to drill 6 inches from the end, 6 inches from the other end, and 24 inches on center, so that when we set the frame in the sill flashing, we can run these screws through down here to attach the sill to the sill flashing. Okay? That's how we designed our sill and our sill flashing at YKK. Now, these guys that run the screws through the back of the sill flashing, are the threads on that screw enough to manage the end reaction?
No.
Maybe not. You know, if they're running those screws every 4 inches, maybe it's enough. But what you're relying on is the pull-out strength on those screws. They're typically using like number 10 screws down here. I would bet that you could pull that apart with your bare hands if it was just like one screw every vertical mullion or something like that. Okay. The other thing that you could do, which is what the Conniers do and what we used to do, is you drill a hole in the sill. You drill a hole in the sill flashing, and you drill down into the concrete, and you countersink this hole, and you run a fastener down in through here, right? That's how you were supposed to do it back in the day. And then that screw, instead of relying on the pull-out strength of the threads, you're relying on the shear strength of the screw, which is very, very high, okay? But the problem is what? You're penetrating the sill flashing, and it's very, very difficult to make sure that that's effectively sealed. So we get around that by using these little fasteners in a way that does not penetrate the sill flashing. That's what this little channel is for in the front of the sill flashing. It's for you to mechanically attach the sill to the sill flashing without having to penetrate the sill flashing. You guys with me?
Yes.
Okay. So that's why our sill is shaped the way it is. That's why the sill flashing has this little channel, and that's why we need to drill these holes the way we do to handle that, to manage that end reaction that occurs when you get a wind event. Does that make sense to everybody? Okay. And these screws, by the way, just so you know, when we go to install them, they're stainless steel screws, so they're not going to stick to your magnetized apexes. They're kind of a pain in the ass. But what's that?
Especially when you're trying to fish them out.
Yeah, when you're trying to fish them out, I understand that. But here's the reason that those are stainless steel is because this channel right here, during a wind and rain event, you may get these screws sitting in water for a period of time. Now you'll notice here, there's a little lip on the edge of where we're going to drill the hole. That raises up the head of the screw a little bit so that water can drain. So this will drain around the screw, but it drains into the sill flashing and can drain out to the exterior. Does everybody follow me? So when you're installing these, we do not want you to seal these screws. Okay? You haven't been, right? Okay, good. Good. Yeah, we don't want these sealed. Those are just preventing the end reaction, and if water gets in here, that's okay. In fact, if you're ever at the job site, you know, if you're not sure about that, just pour some water in here, and just in a couple of minutes, it'll be gone. Okay? Any questions about that? And we'll talk about the actual installation of the sill. Right now, we're just talking about the fabrication of the sill and drilling those holes. Okay? Okay, the sill flashing cut length. Okay? We always want to cut the sill flashing a little bit longer than the actual frame width, right? And the reason for that is because any of you that have installed frames in the field, when you're installing that frame, if the frame is the same width as the sill flashing is, then when you're trying to get that end frame in, you're constantly in conflict with the end dam on the sill flashing, aren't you? So we typically want to cut the sill flashing a little bit longer than the frame width. Okay, so typically we want the sill flashing cut length to be the frame width plus 1/8 of an inch at jam conditions. Okay, so like on this, if this were a storefront frame right here, this 18-foot opening, you would have an extra 1/8 of an inch on both ends. Okay, because we have 2 jam conditions. If you have a door jam, this is a jam and this is a jam, so you have the extra 1/8 of an inch. Extra 1/8 of an inch. At the door jam, the sill flashing sits tight to the door jam. So you're only going to have the additional 1/8 of an inch at the actual jam conditions. Okay? Any questions about that? If you're running flashing from door jam to door jam, there's no extra. It's just going to be tight to the door jams. Okay? Then as far as the fabrication of the sill flashing goes, we need to drill weep holes in the front of the sill flashing. That's right through this little area. Remember where that screw goes down? We're going to drill weep holes there. Okay? What size weep holes do we need to drill?
5/16.
Why 5/16? What's magical about that number?
Smaller bubble to hold back water.
I'm sorry, say that again. That was good.
It was a smaller than that, a bubble would hold back the water.
Yeah, what he's saying is, if you have a weep hole smaller than 5/16 of an inch, what can happen during a wind and rain event where you have fluctuations in air pressure is, since you've got water in there, you can get a little surface tension bubble that forms over those round weep holes. And again, I'm not a hydrodynamic engineer, but for some reason, when the bubbles are real small, the surface tension on the bubble is very, very strong. Strong enough to prevent water from draining out. You make those holes a little bit bigger, 5/16 of an inch, that's enough to weaken the surface tension on the bubble enough to where the weight of the water can break the bubble and allow it to drain. So the reason that is significant is back in the days that I was a fabricator, we were never allowed to drill round weep holes. We had to do weep slots, right? Which was tended to be, obviously, anytime you have to do a slot versus a round hole, it's going to be a little extra fabrication effort. Certainly not a lot, but maybe you take the drill bit and kind of wallow it out and elongate it. That tends to chew up the finish a little bit, both inside and outside where you're drilling the hole. Or you have a punch press, or you have to drill 2 holes and file it down. And the reason was because they didn't want to have round weep holes because of the potential for bubbles to build up. But fabricators know how much easier it is to just drill a round hole. And so that led to, okay, we can do round weep holes, but they have to be 5/16 of an inch. And you'll see that as a common theme, whether we're talking about weep holes in storefront systems, or weep holes in window wall systems, or weep holes in curtain wall systems. If we have round weep holes, they need to be a minimum of 5/16. Okay? And if you think that's not important, take my job for a little while. I can't begin to tell you how many job sites I go to where the only problem I find is that either they didn't drill the weep holes or they drill them too small. Okay? And it's like, I go out there, your weep holes are too small. Oh, I don't think that's why it's leaking. I'm just going to say, look, I need you to try to install this in accordance with our installation instructions. And if you still have a problem, then we'll talk. But I need you to do it the way we say to do it. Like I said, there's nothing in here that's random. And the size of those weep holes is certainly not random. Now, with our hurricane impact systems, we actually have slightly larger weep holes than that. We have 3/8 of an inch weep holes. But that's because of the potential moisture infiltration that we might get during a hurricane, event. Because we're still, even though we're trying to just keep the building intact during a hurricane, we also want to reduce the likelihood that we're getting leaks. So, first of all, 5/16 inch weep holes. The other thing that is very important is the actual location of the weep holes. Okay? So if this is, what you'll notice it says here is sill flashing weep holes, 5/16 of an inch, 2 per daylight opening. and they should be located at quarter points of the daylight opening, okay? So if you're looking at the storefront from the front, like an elevation view of the storefront, here's your jamb mullion coming down into the sill flashing. Here's your intermediate vertical. What we want is we want you to come in at quarter points of your daylight opening, and that's where you're going to drill your 5/16 inch weep holes in the sill flashing, okay? The reason that's important is because what I'm seeing a lot of is people that drill the weep holes right underneath the vertical mullions, okay? Which in and of itself isn't bad, but it becomes a performance problem during a wind and rain event or during a field water test. How many of you guys have ever had to stand there and watch while they do a field water test on your installation? That can be kind of uncomfortable, can't it? Right? But let me explain what happens when you have a wind and rain event or when you have a field water test. You have pressure differential between the inside and the outside. Typically, you're going to have very high air pressure on the outside and relative to lower air pressure on the inside. That causes water to want to build up inside the sill flashing, okay? And I'll cover this when we talk a little bit later about drainage. But what happens is water will build up inside the sill flashing before the weight of the water becomes enough to offset the difference, and then the weep holes will start draining. And that's not just during the test. That can happen during a wind and rain event, bad weather too, okay? If you have a weep hole directly underneath your vertical mullion, the high pressure on the outside can actually cause air to want to be sucked into the sill flashing through that weep hole, okay? If the sill flashing is also full of water and you're getting air sucked in through that weep hole, what's going to happen to that water in the sill flashing? It's going to percolate and it's going to splash. And if it's doing it right here underneath the jamb mullion, that means your end dam is right here. What happens to that water? It splashes over the end dam and you got a leak. That's why we want those weep holes at quarter points of the daylight opening. Keep them away from the end dams. Then if the water back here is percolating, let her go. Doesn't matter because it's too far away from the end dam to splash over the end dam. Okay? Quarter points, 5/16 of an inch at quarter points of the daylight opens. Okay? Any questions about that? Okay? Again, that's for typical applications. Again, if we had, let's go back to this example right here. If this was an 18-foot wide opening and it was butt glazed, do you think we would want to just put 2 weep holes in that opening? So again, if you have unusually wide openings between vertical mullions, then you may want to consider adding extra weep holes, okay? How long are our sill flashing stock lengths? 24 feet. So is it possible that our storefront run could be longer than 24 feet? Yes. So remember we talked about if the frame width is over 24 feet, you need to put an expansion mullion every 12 to 15 feet, correct? Same rule for the sill flashing. If your opening is longer than 24 feet, you need to splice the sill flashing every 12 to 15 feet, okay? So if this opening is 24 feet, you can lay 1 piece of sill flashing down, okay? What if it's 30 feet? Yeah, you're going to have to splice it because our sill flashing is only 24 feet, right? Where do you put the splice joint? Do you splice a 24-foot piece to a 6-foot piece? No, you have to go, if it's over 24 feet, you have to splice it every 12 to 15 feet. That 24-foot sill flashing, remember what I said about the coefficient of expansion? 24 feet, that's going to want to expand and contract 5/16 of an inch. That's a lot, right? We don't want that, okay? If it's 24 feet long, it's going to want to expand and contract too. But we have what? We have 3/8-inch caulk joints at the ends. So it has room to move, okay? As you're going along in a long run, you're running out of room. You can still move at the ends, but now the flashing is getting longer and longer. So we need to splice the sill flashing every 12 to 15 feet. And we need to make sure that when we're splicing the sill flashing, we're leaving about a 3/8 of an inch gap between the ends of the sill flashing to allow it to move, okay? So I think probably historically people have tried to butt the pieces of flashing together and then just caulk the heck out of them. Can they move if you do that? They can't really move, and so something's going to give. Usually that leads to sealant tearing and leaks occurring, okay? So we need to leave a little space between the ends of the flashing at the splice joints to allow it to expand and contract, okay? And we'll talk about the construction of the splice joint a little further on, okay? Any questions about that? Have you guys so far, have you found that you're already doing things the way we talk about, or are you picking up on some things that need to be a little bit different?
A little bit of both.
A little bit of both? Yeah, that's good. But yeah, there's always room for improvement, right? Okay. Now, after you've cut the horizontal and vertical mullions to their appropriate length, and you get to the point where you're ready to start assembling the frames, it is necessary to apply sealant on the aluminum frames at certain locations as you're assembling them, okay? And what I'm showing here in the booklet on page 14 are the areas on the horizontal mullions where you need to apply sealant prior to screwing the frames together, okay? And I've kind of highlighted it over here. You guys are laughing. The guys yesterday told me this isn't being done. Okay, and like Jody said, I'm kind of tracking this stuff. And there was a lot of discussion about, oh my God, if we have to do this, it's going to add time, and you need to tell the guys in the office that some of these things that we're not doing, and we understand that. I understand that, and they understand that as well. What everybody wants is they want it done right the first time so that you don't get leaks and callbacks and things like that. I would also, just to not set your mind at ease, but just sharing my experience with you, is that if you're not doing things the right way and you're worried about the added time it takes to do it the right way, my reaction to that would be, I think if you start making the right way your habit, you're going to find that you can do it the right way pretty quickly too, okay? So just kind of keep that in mind as well, okay? But obviously, before you apply the sealant, what do you need to do to the metal? You need to clean it. Again, with whatever type of sealant you're using, make sure you're using the appropriate cleaner. And you can see, what some guys do when they're assembling these is they'll apply sealant to the entire profile of the horizontal member before they screw it together. And I don't care if you want to do that. But at the very least, you need to do it in the areas where we show it. And what you'll notice on the horizontal mullions is that the areas are all right by what? The screw splines, right? And same thing here at the sill, and if you're doing inside glazing. One thing I want you to look at, and a lot of people miss this, on the horizontal mullion, you see this backer rod and the sealant there? You guys see that? Okay, let me explain to you what's going on there. This backer rod does not run the entire length of the horizontal mullion, first of all, okay? It's just a small piece of backer rod. So you just take a backer rod, take a pinch off of that backer rod, and stick it right in the end of the horizontal mullion on both ends, okay? And then you're just going to put a skin of silicone over that in addition to the sealant you're running on the horizontal mullion right there. Do you see that? Do you guys understand what I'm describing to you? Okay. What that's for is, again, during an extreme wind and rain event or during a field water test, what are we going to put on the ends of the horizontal mullions to divert water down the vertical pockets?
Water deflectors.
Water deflectors, okay? So the idea is that water that enters the system builds up on the horizontal until it migrates to the ends of the mullions, and then it drips off the water deflectors down the vertical mullions. Excuse me. During an extreme wind and rain event or during a water test, you're going to be trying to suck air through the framing system on the inside. And what can happen is, in this little hollow area right here, water, instead of dripping off the end of the water deflector, can get sucked into this horizontal mullion back here on the inside, and it becomes a leak on the interior side. So what we're doing is we're preventing the likelihood of that happening by capping off this hollow at the ends only in order to prevent air from sucking water off the end of the water deflectors. Does that make sense to everybody? What's that? I know. We talked about that yesterday too. We'll get to that later. Okay, don't worry about the water deflectors now. We'll talk about that later. I got a mixed reaction yesterday. Some of the guys didn't even know what water deflectors were. Others did. Some of them said you didn't use them. Some of them said you did. I said, I'll bet you guys have got boxes of them here. Some people said you did. Some people said you didn't. These are the kinds of, that's why we're doing the training, is because these are the kinds of things that need to be done. Whether you're aware of it being done now or not, these are things, the way things need to be done, moving ahead, if you expect the system to perform the way we want it to perform. Okay? So then also, again, look at the vertical mullion. This is showing the pocket filler, but you're going to do the same thing on the female mullion half and then the jams as well. Where the horizontal attaches, we want you to put sealant in the glazing reglets at the horizontal mullion locations. Do you see that? Okay. What that's for is when we drain water out of the system, we only want it to be able to run down the vertical pockets to the sill flashing where it can then drain out the weep holes, correct? What we don't want is we don't want to have water running down the glazing reglets. Because if you have water running down the glazing reglets, then what happens is when it gets to the underside of the horizontal and it gets to the top of the glazing reglet below that, it'll build up and it'll come in on the underside of the horizontal mullion and get on top of the glass. And if it gets on top of the glass, you're going to have two problems. One, it's going to start leaking from the underside of the horizontal mullion across the inside face of the glass. And two, with that water sitting on top of your IGUs are going to fail and they're going to fog up. You guys ever seen fogged up glass? Okay, there's two general causes for that. By the way, the insulating glass units that you guys are installing, what are they typically sealed with? They're not sealed. They're not typically sealed with urethane. Anybody know? There's usually a hot melt butyl that they're using to glue it together, and then ultimately what they're doing, the black gooey stuff around the outside, you know what that is? That's silicone. That's silicone. The silicone problem, again, one of the problems with silicone is it's not an immersible sealant. What that means is that if you have an IGU, an insulating glass unit, and it's sitting in water for a period of time, the bond between the silicone and whatever it's sticking to will fail. And then now all of a sudden you're going to allow air and moisture into the airspace in your IGUs. That's why they fog up. So when you're looking at a fogged up IGU, the typical cause could be one of three possible causes. It could be it was just very poorly made. There's always that. More often than not, either the bottom of the glass pocket is not draining and the bottom of that IGU is sitting in water, or they didn't do some of these things properly and water is sitting on top of the IGU and it's failing. Okay? So a lot of these steps are not just related to the performance of the system, but also the longevity of your insulating glass units. Okay? So please, if you're not already doing these types of things need to become standard operating procedures for your frame assembly. Okay? Including putting the sealant in the glazing reglets like this. Okay? This is something that's fairly new, but I'm going to explain to you why we do it now. When you're running your perimeter caulk bead around the frame, okay, you have the perimeter caulk bead on one side, it's sticking to the substrate, whatever that is, stucco, drive it, brick, precast, whatever the heck you're caulking to. The other side is it's sticking to the frame. This is just showing a view from above the head. We're looking down. So this is the actual head mullion right here. This is the pocket filler, the top of the pocket filler. This is the top of the female mullion half, okay? When you're running that perimeter caulking across the top of the frame, it's sticking right to this, isn't it?
Yes.
Okay. What is it sticking to at the top of the vertical mullion? Not much, right? It's at the very least, it's sticking to this right here, which is not a very good surface to caulk to, shall we say. So what we have now is this foam tape. It comes in rolls, and you just cut pieces of it off to fill these spaces at the top of the vertical mullions, so that when you run your perimeter caulk bead and you tool it, you actually have something for the sealant to support the backer rod and for the sealant to stick to. Does that make sense to everybody?
Yeah.
Okay. And we actually kind of list this as being an optional step. I think it's a good step, okay, but it's certainly optional. For example, if you're using the two-piece head receptors, okay, then you're going to be caulking to the head receptor, not to the actual top of the storefront. So you certainly don't need these if you're using a receptor at the head, okay? Also, in a lot of cases, there's not much potential for this to get a lot of water on it. A lot of times the top of the storefront is kind of under a soffit a little bit, but still, you want to limit air infiltration too. But what we found is more and more architects and building envelope consultants are criticizing, not having something up here capping off the top of the mullion. So we've actually started seeing some of our competitors developing, like a plastic cap or a metal cap that you screw onto the top of the mullion. We just, our response to it is using this tape, which is something we've done on our window wall systems forever. Okay, we've just incorporated that step into our storefront systems as an option. Okay, what's that?
I said essentially you could build an end dam too.
You could build an end dam. I think that you'll find that just using this tape, taking your scissors and cutting a piece of tape and stuffing it in there is probably the easiest. In my mind, that's the easiest solution we could come up with.
You usually shim right there.
What's that?
You usually shim right there.
At the top of the vertical mullion? Usually people shim where the anchors are. Well, we'll talk about that, okay? We'll talk about shimming, okay? Any other questions about that? Okay? Sill flashing. You guys, this is something you can do in the shop. Since the sill flashing is going to fill up with water, and we only want the water to be able to come out weep holes at the front of the sill flashing, we have to do what to the ends of the sill flashing? We got to put the end dams on them, okay? And so at YKK, our sill flashing and end dam design is such that we have a flat metal plate with a little tab on it, and then we have these two little holes. The end dams are not handed. There is no right-hand end dam or left-hand end dam. You actually hand the end dam by bending the tab. So if you bend it in the fashion shown here, with the tab sticking out like this, it becomes a left-hand end dam. If you bend it the other way, it becomes a right-hand end dam. Okay? But just putting the end dam on the sill flashing isn't enough. We also need to clean the end of the sill flashing, apply sealant onto the sill flashing, and then we screw apply the end dam on. And the way the screws go in, there's actually a spline in the bottom of the sill flashing, and you've got the channel that runs across. That's where you're going to insert those screws to mechanically attach the end dam to the sill flashing. Okay? After you've screwed it on, you're going to then need to apply and tool a little extra sealant in these areas right here. Gun some sealant on there after you've screwed it on, and then tool the sealant. Be careful if you're the guy that's putting the end dams on. Be careful that you're not putting too much sealant on this. And the reason is because when the guys in the field go to set the frame, if you've got a great huge wad of sealant here, they go to set the frame doesn't go down into the sill flashing because there's too much sealant. Then what do they got to do? They got to dig it out. And when they're digging it out, they might damage the seal and cause a leak. Okay? So one thing that I'll mention this a couple more times. One problem I run into a lot is not so much that people aren't sealing things, which happens, but sometimes they're using too much sealant. And that creates a whole different category of problems. Okay? Any questions about the end dams on the sill flashing? Yes.
So we've gotten into the habit of caulking between the top of the end dam and the rough opening. And I don't think we need to, but we've been doing it for years, so can we officially stop doing
Yes.
it?
Actually, that's something that I see a lot. And historically, I thought, well, that's not a bad idea. That's not necessarily a bad thing to do. But one thing you have to remember is that the sill flashing has to be able to expand and contract independent of the surrounding condition. And when you're caulking your end dams to the surrounding condition, are you potentially pulling your end dam seals apart when you get expansion and contraction? So I would say, yeah, I'd stop doing that. It's an added step that I don't think you need to be doing. On the other hand, sometimes you'll get building envelope consultants or architects that want you to do it, and I guess if
You tell Bart, say no.
I can do that. I can do that. Now, typically, if you guys are, and unfortunately, and it's kind of the nature of commercial construction, we all start out in love with each other at the beginning of the project, right? The general contractor loves the glazing contractor loves their product suppliers, and the architect loves everybody. But as we go through the process of constructing the building, what happens to those relationships? The nature of construction is that they become a little strained at times. And sometimes, people become less cooperative closer to the end of a project. One thing that I do for YKK is when we have a situation that occurs where a contractor or a consultant or an architect wants you guys to do something that we think is bad, then we can write a letter or we can speak on your behalf to that type of thing. Okay? And a lot of time, and my thing, in my role, I get tasked with doing that quite a bit, and I have no problem sleeping at night. I can be an asshole if I need to be. That's part of what the company pays me to be. Sometimes our sales reps like it when I'm the asshole. That way they don't have to be. Same thing with the customers. So in a case like what you're describing, my first advice would be, I don't know if it's that big a deal. I don't know if it's worth fighting about. But if your relationship is eroded to the point where you're fighting about everything, then certainly I would say, yeah, Mr. Architect, I don't think that's a good idea. This is why I think it's a bad idea. I can put that in writing, and then they can decide if they want to take the risk for it. Okay? So let's say I write a letter saying, no, don't do this. We're worried that expansion and contraction could put a strain on the end dam if it's somehow adhered to the substrate and you get expansion and contraction. And the architect's going to read that and he's going to understand exactly what I'm saying. But like I said, usually at the end of the game, we all hate each other and people are getting to be stubborn and say, I want it done anyway. And now what we've got is we've got a written record that we showed them. And then if there were to be a failure down the road, we can say, hey, we kind of warned you that this might happen. Okay? So there's a lot of things like that I get involved in. It's nitpicky, it's petty sometimes, but we're looking out for, my job is to look out for YKK's best interests, and when I can, your best interests as well because you guys are our customers. You know what I mean? So yeah, that kind of stuff happens, and we just kind of deal with it as it comes up. But yeah, officially, I would say you can stop doing that unless you run into a conflict where somebody's raising hell about it. There's other things like that I see. Putting sealant on the pressure plate fasteners on our curtain wall systems is one that I see quite a bit. We don't require that. Okay. Okay. Or how about this one? You guys ever seen this? This guy did not want to waste money on a 25-cent end dam, did he? Instead, what he decided to use was $20 worth of Dow 795 silicone. Okay, which by the way failed, which is why I was there taking a picture of it. Okay.
Looks like there's a couple screws too.
Well, it kind of pulled apart as we were taking it out. The bottom line is it was failing. But yeah, this is what we want. This is what we want our end dams to look like. We don't want them looking like this. Okay. Okay? So the sill flashing splices, remember, what's the rule for splices? If your storefront is over 24 feet, you have to splice it how often? 12 to 15 feet, okay? So I want to point out a couple of things to you. We have a splice sleeve that we use in the sill flashing. So remember I said you need to leave a little bit of a gap here. Well, the way we prevent water from getting down through that gap is we have a splice sleeve where it'll apply sealant, silicone sealant, around the area where we're going to press the sleeve down in. And the sleeve, if you've never seen it before, it's a cured silicone sheet. Okay? It's actually made out of silicone, but it's cured silicone. And we sell it to you guys and it comes in plastic bags. I don't know, there's 25 of them or 50 of them in a bag or whatever the heck it is. You guys get them as accessories, okay? Also, the sleeve is smooth on one side and it's ribbed on the other side. Got little ridges on it, okay? But what you're going to do is you're going to apply sealant on either side of the joint. But before you do that, you guys see this little thing right here? You guys see that with the sill? Is not actually resting on the sill flashing directly. It's sitting on what? We call that a nub. Seems like it could have a better name than that. But the engineer, when I was looking at the detail, I go, what the heck is this? He goes, that's a nub. I said, what's it for? He goes, it's for when you have to splice the sill flashing. So think about this for a second, you guys. Look at the top of the sill and the top of the sill flashing. You see that? They're even with each other. Have you ever seen before where you have a splice sleeve and you put it down in the sill flashing? What happens to the sill when it goes over the splice sleeve? It goes up. And this becomes uneven, doesn't it? Okay? So the only reason that nub is there is so that you can grind it off when you have to put a splice sleeve down in there. Guess how tall that nub is? It's exactly the same height as the thickness of the splice sleeve. Okay? So all you have to do is you can do it with a grinder or a chisel. Just take the nub off, 1.5 inches on both sides of the splice joint, put your sealant down, and then bed that splice sleeve down into the sealant. You want to bed the splice sleeve down with the ribbed side of the splice sleeve going down into the sealant. Okay? Why is it ribbed on one side? What's that? Anybody know why it's ribbed on one side? Yeah, so remember, whenever you're applying something with any kind of adhesive, silicone in particular, there is a cure time. There's a time where you develop adhesion, and there's a time for it to cure. Okay, that time may be depending on the temperature and the humidity at the time you're installing it. It might be a matter of a few minutes, or it might be a matter of a few hours. In the case of this, to where you get real adhesion. Okay, but during that time, you could still get expansion and contraction, couldn't you? So what the ribbing on that sleeve does is it creates a little bit of a mechanical bond between the sealant and the sleeve to kind of hold it in place in the event that there's a little bit of movement in that joint prior to getting full adhesion and full cure. Okay? That's why we want the ribbed side going down into the sealant. Okay? Any questions about that?
Now this changed, right? Because before the detail would show that the silicone sleeve would go down into the water trough, right?
Well, it is.
Now it's showing you fill in the whole void and it going flat across. I feel like I remember before the book would tell you to bend it down into that trough.
No, it was never like that. Now, prior to us, and by the way, we've been doing it this way for at least 10 years, if not 15.
Yeah.
Okay. But prior to that, what we had a formed metal sleeve.
Okay.
A formed metal sleeve that you would have to put bond breaker tape on. Okay. And you would fill all this with silicone, and you'd lay that sleeve down in there, and you'd put bond breaker tape on the underside of the sleeve. But no, it's always been like this, as far as since we've been using this, which I want to say has probably been 15 years. Okay. That's a good observation, and what you're probably thinking is the details of that formed sleeve and the way it used to fit.
Yeah, maybe I feel like that's how it said in the book before, but
down. Okay? That's a good comment, though. Any other questions about the splice sleeve? Where should the splice joint be located?
Center of the element.
Yeah. Well, we don't. Well, it says here. It says center. I think it says. It's actually in the fabrication instructions. What it says there is we want the splice sleeve located at the center line of a daylight opening. The truth is, we want it doesn't have to be directly in the center of a daylight opening. What we don't want is we don't want it to be directly underneath a vertical mullion. Okay, a lot of guys think that I'm going to put the splice right under the vertical mullion. That way the line in the sill flashing will line up with the vertical mullion. But the problem with that is, again, we have a piece of silicone, soft, stretchy silicone sleeve material and silicone sealant. When you cut those mullions, what the ends of the mullions are very sharp, aren't they? And if you put a vertical mullion directly on this sleeve right here, as soon as you start putting glass in the framing system, it adds weight to that vertical mullion. It can dig into this and cut it. Okay? So what we call out here is we want the splice to be at the center line of a daylight opening, but it doesn't need to be exactly in the center. All we really want to avoid is having the splice be underneath the vertical mullion. Yes, sir?
What do you do in the case of a large corner?
I'll show you that next.
Does it matter if the caulk we're putting into the subsill is polyurethane?
It needs to be silicone. I think I said that in the beginning. So normally we don't tell you what needs to be used, but in the case of this splice sleeve, it needs to be silicone. And the reason is because this is also made out of silicone. So,
I'm sorry, I don't mean specifically for this. I mean for anywhere.
oh, you could use whatever sealant you want to use. Okay. Now again, we've designed all of our glazing components, the gaskets, the setting blocks, everything now is silicone compatible, which tends to add to the cost. And the reason for that is because the industry is, especially in commercial construction, is moving universally towards silicone because of it's more expensive, but it's UV resistant. So you can get a 10, 15-year warranty on silicone. You will never get more than a 5-year warranty on polyurethane. Have you guys ever had to dig old polyurethane out and recaulk a joint? Anybody ever had to do that? Yeah, within it, depending on how much UV it gets subjected to, it gets hard. It gets like it's almost like grout, right? And you're basically chipping it out. Well, if your sealant gets hard like that, it's losing a lot of the properties that make it effective in the first place. Its ability to stretch, its adhesive ability, all of that fails as the silicone gets, or as the sealant gets hard. Silicone never gets hard. Okay? Would you guys know why silicone? Hey guys, do you know why silicone sticks so good to glass? Anybody know why? They're both made out of the same thing. Silicone is made out of silica, which is what? Sand, right? And that's what glass is made out of too. That's why they stick together so well. Okay. Now, as far as other things, it varies. You know, you guys, if you're using silicones, you may have to use primers every now and then, right? But the same thing is true for polyurethanes. They have primers for those as well. Okay. But the key thing with silicone is it's chemically inert. It's UV resistant, and it can stay in its cured state, effectively sticking and effectively being able to stretch and so forth for an undetermined amount of time. Okay, polyurethane not so much, but we don't really tell you what kind. There may be reasons you need to use polyurethane sealant. For example, let's say your perimeter caulk bead is coming into contact with a building control joint that's going to be sealed with polyurethane. They may object to the point contact between a silicone perimeter caulk bead and the polyurethane control joint in the building. And so they may require silicone be used for that reason, or polyurethane be used for that reason. Another reason is, it's kind of embarrassing, but when I was working for Tremco, one of Tremco's best-selling polyurethane sealants is Vulcum 116. Any of you guys ever worked with Vulcum 116? That's old school. I mean, that's really old school. But do you know why the architects like it? Do you know why the architects like it? Because it looks like brick mortar. It's kind of got that grainy, gritty. It's not smooth. It looks just like brick mortar. So if you get it like in a gray or something, it doesn't look like caulking. And they like that, especially on a brick building or something. So there may be reasons. We're not here to tell you. We can have a discussion about our opinions of what we think is best. Some guys like the polyurethanes better because they think they're not as finicky as the silicones. Oh, I can go out and caulk this thing in the rain and it's going to stick. Now, is that true? I don't know, but there's people that go to bed at night believing that, So, and as far as the durability goes, if you're caulking a joint in a sidewalk, right? They're typically using polyurethanes for that, self-sealing, self-leveling polyurethanes for that. And the reason they're not using silicone is because silicone is softer than polyurethane. And if you're walking on it or if you're driving cars over it in a parking garage, typically you're not going to want to use silicone because of the wear factor, okay? Did anybody here ever installed deck coatings before? Like on balconies or in parking garages where people are walking on it or driving, those are polyurethanes, okay? So we think that as far as glazing goes, silicone is the best way to go, but that doesn't mean other sealants can't work, okay? Anybody here ever worked with butyl? Yeah. So when I was a fabricator, back in the day, all this sealing that we did, none of it was done with silicone. We used butyl for everything. In fact, when we were fabricating 1600 wall for Conair, we would get the pressure plates in. And you know how like when you get our pressure plate, it's got that gasket running down the middle of the pressure plate? The Conair pressure plates would show up and they had butyl tape where the gaskets go and a butyl spacer in the middle. And of course, the first thing we do is peel that stuff off because when you start cutting it, then the metal chips would get embedded in butyl tape. But everything was sealed with butyl back then. Okay? Problem with butyl, well, if you've ever worked with butyl, it's horrible to work with. It's barely a solid. It's like more like water than it is like silicone, liquid silicone. And man, that stuff, if I look at butyl, I would have it all over me. And then you'd have to use things like MEK to try to wash it off. You guys don't work with MEK, that's dangerous stuff. Methyl ethyl ketone, it's a great solvent, but it's dangerous. It's not good for you. So, but that's why things have evolved more to silicone. Now, and again, it varies. Some of our customers never use silicone. They tend to be, doing smaller projects, things like that. The guys that are doing the big projects, the high-rise buildings and stuff, they only use silicone. So it's just kind of the nature of the industry right now. Okay. Any other questions about the splice joint? Okay. So this is what your properly installed sill flashing looks like. It's shimmed up. How much are we shimming it up? 3/8, a minimum of 3/8. We want it needs to be level and it needs to be plumb. We don't want it leaning towards the front or leaning towards the back. It needs to be plumb, okay? We have our end dam sealed. We have our splice sleeve in there, sealed in place. And any fasteners where we're attaching through the sill flashing and into the substrate, those fastener heads need to be cleaned up and sealed too, right? Okay? This is showing what happens at the end of the receptor. If you're using the two-piece receptor at the head, we have little end caps that go on the receptor. All the end caps are for is, again, when you're running your perimeter caulk bead, it gives you something for the sealant to stick to up there at the receptor.
All right, I'm sorry.
Yeah.
Can you go back 2 slides?
2 slides.
We put caulk, maybe one more slide. So we put caulk along the top and back edge of the subcell.
Yeah. I haven't gotten there yet.
Oh, I'm sorry.
That's okay. No, that's a good question. That's an excellent question. We haven't quite gotten that far yet. Okay? You're good. You're good.
He's more advanced than us.
He's thinking faster than I can talk. Okay, so who asked a question about okay, so here's what we want you doing at the corners, okay? When you have a corner condition where your storefront, we tend to think of storefronts running straight, but occasionally you have to do what? You have to turn a corner, right? Whether it's a 90-degree corner or a 45-degree corner or anything else that causes you to need to miter cut the sill flashing, right? You guys all know what miter cutting is, right? So instead of a straight cut here, we're cutting it at an angle, okay? And this is just showing, this happens to be showing a 90-degree angle, okay? The problem with these miter cut joints is there's no way physically to splice them together in a way that can accommodate this joint moving, okay? And the reason is because it's wanting to move, and basically, it's like if you have two pieces lined up straight, it's what we call a two-dimensional splice. When it's coming in at a miter, that's a 3D miter, and we don't have a sleeve that can accommodate the movement there. So we're going to install this in a way that doesn't allow for movement at the miter joint, okay? So what we're going to do at the corners is instead of taking long pieces of flashing and mitering them and butting them together in the corners, what we're going to do is we're going to take small pieces, basically from the apex of the miter back 12 inches, 12-inch long pieces. Do you see that? And then we're going to anchor these down onto the substrate, and we're going to caulk this. All right? We're just going to caulk that. Then we're going to put splice sleeves here and here. So as you're getting expansion and contraction on the sill flashing, okay, we're going to manage the expansion and contraction here, and that takes all the stress off of the miter.
That's no matter how long they are?
Well, not necessarily. If you've got a small corner, 2, 3 feet, 4 feet, something like that, you probably won't get enough expansion or contraction to where that's going to want to pull apart. But you're talking, anything over probably 6 or 7 feet, you're gonna need to do something like that. Okay, and the reason for that is because I see a lot of leaks where they've got leaks at the corners, and you go up there. More so, you'll see it in the wintertime. If you ever see a storefront that's installed, if you see it often enough, look at the corner when it's hot outside, and then look at that same corner when it's cold outside. And what you notice is when it's cold outside and this is shrunk, then you're going to have a gap right here. And if you have a gap right there, this sealant, again, that can't be done in a way to allow the sealant to stretch. So we just take the stress off by splicing it at these locations.
So should that corner be like fabbed and glued together and then installed, or
It doesn't have to be, although it's interesting that you mentioned that. We do have customers that will create this and they will literally weld that together. Okay? And I've actually seen architects write that into their specs. I don't think that's any more effective. I think that when you have, these high-end projects with building envelope consultants and architects, they sleep better at night knowing that this is welded together rather than the thought that they're relying on the workmanship of a field guy to make sure that it's effectively sealed. Okay? So the answer is it can be done either way. If you guys decide that you want to literally weld this together, you can. Of course, whenever you're welding, architectural aluminum that's finished with, Kynar paint or anodizing, you run the risk of discoloring it due to the heat. So that's a concern too. So in my mind, this is the better way to go. Okay? That's a good question about the corner, though. That's a good discussion for us to have. Okay? Any other questions about that corner? You guys think now's a good time to take a break? Yeah. I've been noticing sitting there moving and jumping around like my 6-year-old grandson. So let's take 10 minutes. Hey guys, ladies, 10 minutes. Try to be prompt, okay?
Especially like we're in a high water environment already.
The biggest thing is the style. Hopefully, the Chinese guys get better.
I would say I have never seen that.
We don't do it.
I'm kind of curious. I don't know.